Okay, guys, we're going to try to make a recording here, the first one on the iPad, explaining the ambiguous case, because I want you to have something to refer to in this situation. If all goes well, we'll try to do one on the unit circle as well. But let's see if we can hammer out one on the ambiguous case in your book. What we were doing with the ambiguous case is on page 598, and I want to look at, to begin with, problem 7. Now, if we need to look at 8 and 10, the other two I assigned you, please shoot me an email or a text, and I'll try to get those together for you. But right now, I just want to make sure that you have a way to go back and study how to find the two triangles if we have an ambiguous case. All right, number 7, the one you had in your homework, we have that side A is 14, side B is 16, and the measure of angle A is 55 degrees. So we're going to draw that out. Now, the way I'm drawing it isn't the have to. It's just sort of the way we've been drawing these in class. So if we kind of agree to set them up like this, we can have a discussion, I think, in which we all can engage better. But this is not a have-to situation. I just usually put the angle that I know down here and its side across over here, and then my angle B over here. Now, once I get, see, because angle B is here, and then 16 is side B. I think I said angle B. So now that I've looked at my scenario over there, I see that I have a side angle. And if I have a side angle, then I have to look through that and check to see if I have the ambiguous case or not. I may not. I may have 0 triangles. I may have just 1 triangle and can easily use just the law of sines to find those missing pieces. Or I may have the ambiguous case, which really is not too much more difficult. It just sort of adds another half or 3/4 of a step to my problem. So let's go ahead and check to see, with my side angle scenario, what kind of situation do I have here. Step 1, we always find H, which is our height. Okay, so here's our H. That H is a height, an altitude, so it created a right triangle. Right, let's see if I can outline that. Y'all bear with me. I'm trying to... Okay, so I'm looking at this triangle here. Yeah, I highlighted it for you. So hopefully that works. Okay, so we're going to look at that little right triangle, and we see that with respect to our angle of 55, that we have a sine function that we could use to find H. So the sine of our 55 degrees equals the opposite side of 55 over the hypotenuse. So 16 sine 55 is the height of the triangle. So I'm going to put 16 sine 55 into my calculator, and that's going to give us that the height is approximately 13.1. Now we're ready to run that 13.1 through our list of possibilities. Our first possibility we want to look at is perhaps we have no triangles. So if we have no triangles, let's look at the comparison we need to see. We're going to compare and see, is A less than H? If A is less than H, if the answer to that question is yes, then we have 0 triangles. Well, A is 14, and H is 13.1, so the answer to our question is no. So that means we do have a triangle. Now we have 2 scenarios to look at. Let's see, does A equal H? Because if it does, we have 1 right triangle. Well, does 14 equal 13.1? No. So we don't have a right triangle. Let's compare A and B. If A is greater than or equal to B, we have one triangle. A is 14. Is it greater than or equal to 16? Nope. So now let's look at our last option. Does A come between B and H? Well, H is 13.1, B is 14, or rather A is 14, B is 16. Yes. Since this is true, this means we have the ambiguous case. Or we have two triangles that can be formed from the measures they gave us in the original problem. Ambiguous means something can be taken two ways. So our information here can be taken two ways, one for one triangle and one for the other. So now that we know we have two triangles, we've got to look at the case for each one. So let's make a case for the first possibility. Case 1. In case 1, we know that angle B is 55 degrees. We do not know, angle A is 55 degrees. We do not know angle B. We do not know angle C, but we have to find them. We know that little a is 14 degrees and little b is 16. That means the sides across from big A and big B. And then we don't know the side across from C. That's another unknown. So we have 3 knowns and 3 unknowns in case 1. All right, let's find angle B first, and we're going to use our matching set that's given to us with our A. I'm looking for an angle B, so let's put sine of 55 on top. So the sine of 55 is to 14 as the sine of my missing angle B is to 16. I'm looking for an angle, so I've got to be ready to inverse sine on this pretty soon. When I cross multiply here, I get that 14 sine of B equals 16 sine of 55. I'm going to divide each side by 14. So the sine of B is 16 sine 55 over 14. So I need to inverse sine this. So I'll do second sine so that my display shows the -1 there. And I'm going to put in 16 sine 55 divided by 14 and see what angle B would equal to. So I'm going to put that in my calculator right now. I'm going to inverse sine 16 sine 55, and I'm going to close that parentheses around that 55. Then divide by 14, hit enter, and I find that B has an approximate measure of 69.4. Now, angle C is going to be easy to find because I can add my 55 plus my 69.4, and I can take that sum and subtract that from the 180 degrees that's going to be in the triangle, and I see that C is 55.6. Now, if you'll notice, A and C are very close in measure, so that means little a and little c better be very close in measure. We've almost got an isosceles triangle here. All right, we're ready to find little c. So I'm going, since we're still in case 1, I'm going to keep using my blue pen. And I'm going to say that 14 is to the sine of 55. Remember we said when we're missing a side, it's easier to put the sides on top? Not required, just easier. Now, we're not looking for an angle, we're looking for a side, so we've got just some plain arithmetic really going here. Cross multiplying. Then divide each side by sine 55. So 14 sine 55.6 divided by, let's Pen's giving out on me. Sine of 55. So I'm going to put out my calculator. 14 times sine of 55.6 divided by the sine of 55. All right, it's giving me 13, but I don't recall that being my answer. So let me put that in again. We're going to drop that in. 14 sine 55.6. I'm going to close that parentheses and divide by sine of 55. Yeah, that's 14.1. I didn't close that parentheses a while ago. You see how close that measure is to the 14 there? So that's case 1. We have 2 cases. Case 2, interestingly enough, has the same given. So case 2 also has that angle A is 55 degrees. It also has that little a is 14 and that little b is 16. We still have to find those same 3 missing pieces. Now remember, we have to bridge the gap from case 1. There's got to be a bridge that gets us to case 2. And we said that bridge is that we have to take 180 degrees and subtract what we found as our angle in the first set of, the first case, to find out what the new angle is that we're going to use for angle 2. So let's go back up here to the top. You see that 69.4 was the B. So let's come down here again. To find B2, we're going to take 180 and subtract B1, which was 69.4. So our second possibility for A, or rather for B, 180 minus 69.4 is 110.6. So my second scenario here is that B is 110.6. Now, if that's the case, I can find angle C easily. 110.6 plus 55. Subtract that from 180 to find how many degrees are left to be in angle C. So our C has to now be 14.4 degrees. Now I think we just have one situation to count through for the law of sines, and we'll have this final measure. Since we're missing a side, let's use the side on top for angle A. So the side across from A, 14 over the sine of 55 equals little c over the sine of angle C that we just found. Now, as we cross multiply, 14 sine 14.4 equals C times the sine of 55. So if I divide each side by the sine of 55, 14 sine 14.4 over sine of 55 should give me that final C. So we're going to go to the calculator. 14 sine 14.4, close parentheses, divide by sine 55 equals 4.3 approximately. Now you can kind of see if, not exact measures, but remember, your longest side is going to be across from your biggest angle, which would be B in this case. Your smallest side, what we just found, the 14.3, is going to be across from your smallest angle. So you can kind of get a feel, at least a little check there, that to see if you've got something reasonable going on. Again, if you have any further questions, let me know. If you need to see number 8 worked out or number 10 worked out, number 8 had 0 triangles and number 10 had 1 triangle, please slip me a message and I'll try to get us a video up on those so you can look at them. Also, let me know how you're liking this video or these videos. This is the first one I've done on the iPad, and I want to see how you think this is going to help you having a little mini lecture at home if you need it. Thanks a lot, guys.